Hello and welcome back to another video of this channel. In this video I'll be demonstrating the concept of Norton's theorem, and to make things a little bit clearer I will be solving this exercise and I'll be converting this one into the Norton equivalent circuit. So stay tuned and watch the whole video. Alright, so first of all we need to look at the definition of Norton's theorem. The Norton theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source and a equivalent resistor in parallel connection. And if that's the case, then it will look like this. There will be a current source which is I Norton, and there will be a resistor which is denoted as R equivalent, and both of these will be in a parallel connection. So this is the ultimate circuit of the Norton. Now let's get back to the exercise that we were supposed to solve, like this one. So how do we do that? Let's find out. Okay, so first step should be finding the Thevenin voltage. We all know how to find the Thevenin voltage, and you can take any measurement for finding that one, but for me I'm gonna use mesh analysis. So if we apply mesh analysis on both of these meshes, what do we get? Like in the first mesh, there will be the current I1 equals to 2 ampere. Why? Because there is already a current source in this mesh, and if that is the case, the current in this mesh is supposed to be equal to the current source. I mean, that's what the mesh analysis states. So the current I1 is 2 ampere, and then for mesh 2 there will be an equation in this form, like minus 12 plus 4i2 minus i1 plus 8i2 plus 5i2 plus 8i2 equals to 0. Now notice that I1 was supposed to be 2 ampere from mesh 1. So if we put the value in this equation and solve the whole thing, then we will get the current I2 equals to 0.8 volt, which means the I2 0.8 ampere, sorry, I made a mistake in here. It will be 0.8 ampere. So this 0.8 ampere is flowing through this 5 ohm resistor, and if that's the case, then we can easily find the Thevenin voltage. So Thevenin voltage will be equal to the voltage across this resistor, and that is 5 ohm into 0.8 ampere. So it will be 4 volt. Okay, so we got our Thevenin voltage, and the next step is to find the equivalent resistance. Just like we did in Thevenin's theorem, the same application will be applied in here. For this case, we will be deactivating all the sources, like this current source and this voltage source will be deactivated. So a deactivated current source means an open circuit, and an inactive voltage source means a short circuit. So you can see there is an open circuit there. The whole branch has been removed and the voltage source in here has been shorted. So if we find the R equivalent, then we will see that these 3 resistors like 4 ohm, 8 ohm and this 8 ohm are in series, and these 3 resistors are in a parallel connection with the 5 ohm resistor. So if we do the basic calculation and if we do the math, we will get our I equivalent equals to 4 ohm. So we got our Thevenin voltage equals to 4 volt, our equivalent resistance equal to 4 ohm. Now our third and final step is to find the Norton current. How do we do that? We'll just plug in the values of the Thevenin voltage and equivalent resistance, just like that, V equals to IR or I equals to V by R, and if that's the case, Norton current IN will be equal to 4 by 4 equals to 1 ampere. Now as per the definition, we will install this current source with this R equivalent in a parallel connection. So our Norton's equivalent circuit will be looking like this. You see the 1 ohm current source, which is this one, is here, and the R equivalent is here, and they are both in a parallel connection. So this is the Norton equivalent circuit. So that's the process of converting any circuit into equivalent Norton circuit. Just keep the basics in mind that there is 3 steps. First you have to find the Thevenin voltage, then you have to find the equivalent resistance, and then you have to use those 2 values in order to find the Norton current. So that's it. I hope you found this video helpful, and if you have any confusion regarding this whole process, let me know in the comment section.